types of, yeah, it's kind of a theoretical topic. So, but it's a types of RFCs here. RFC connection types are different. RFC types are different here. RFC connection types means we go to the SM59. So we have the RFC connection types here. Above to above connection, right? Then HTTP connection. So then internal connections. Then TCP/IP connections. So we have the multiple types of connections are there in the SAP system. Multiple types of connections are there in the SAP system here. These are the RFC connection types here. Apart from that, we have the one more concept in the same, that is called the types of RFCs here. Types of RFCs here. So how many types of RFCs we have in SAP here? How many types of RFCs we have here in SAP here? So we have total 4 types of RFCs here. 4 types of RFCs here. One is called the synchronous RFC here. Sync. Okay. Synchronous RFC here. Sync RFC, synchronous RFC. Then second one is the async RFC here. Asynchronous RFC here. Right. The third one is called the transactional RFCs here. So transactional RFCs here. The fourth one is called the qRFC here. These are the 4 types of RFC connections we have in, so sorry, 4 types of RFCs we have in the SAP here. So what is mean by synchronous RFC here? Synchronous RFC. So let's start discussing about the synchronous RFC here. Synchronous RFC means here, so RFC means the connecting between 2 systems, right? The connecting between 2 systems here. This is the one SAP system. This is the secondary SAP system here. The connection between the 2 SAP systems, we have to do it in the, so via RFC administration. So the synchronous means synchronous RFC is the reliable, and also it is a consistent process to transfer the data between the systems here. So which means to transfer the data from this system to this system, so both the system source and the target system should be available. Here. So to transfer the data, both the systems should be available here, right? To transfer the data. So in the source system, wait. So when data transfer completed, then data will go to the target system here. Then it will sit the data here. Then it will send the acknowledgement back to the source system. Then again it will send the one more data to, it's a reliable, and also synchronously it will send the data to the target system here, right? So the source system wait until the first process has been completed at the remote system. Then the program is free 1 second. Then it will process the next system here. In case of the target system is not available, then source system will not send any data. It will go to the sleep mode until you have the system is available, which means at the same time in the synchronous RFC means at the same time both the systems should be available. Suppose in my mobile phone to your mobile phone, Bluetooth transfer, I am trying to transfer the data. Then so I am trying to transfer the data. Right? So I'm just transferring via Bluetooth mode. I am transferring the data to your mobile phone. Just movie or some song I am transferring to your phone via Bluetooth, right? So it means your system, your phone should be available. It should be reliable. It should be available. Then only I can transfer the data. One document completed, then second document. One document completed, second document. Like that, the series, like that, the synchronously I can transfer the data, right? Synchronously I can transfer the data here, right? So there is a one more method that is called the asynchronous RFC. It is a quite opposite to the synchronous here. This is the quite opposite to the synchronous RFC here. Quite opposite means here. So the asynchronous RFC, it's not the reliable process to transfer the data. Asynchronous, right? Why? Because source system only send the data source system will send the data without verifying the target system status, right? And also source system will not get any acknowledgement from the target system about the data transfer, right? Here acknowledgement are not required. Here we are not sure whether the target system will get the data from the source or not. We don't have any information. It kind of like a postcard. Normally we will do the postcard, then so even we will send the postcard, that's it. But we are not sure whether it's received to the target or not, we are not sure. But through via mobile, you are doing the Bluetooth transfer, then so you can transfer the data. Once the first document is completed, you will get the acknowledgement, then second document will be transferred, third, fourth, like that, synchronously, without any issues. You will transfer the list of documents, right? So but in asynchronous RFC, both the systems means even though target is not available, it will transfer the data. So it's not sure like target is available or not. So we don't have any information, means the document is received to the target or not, means basically the source system would not get any acknowledgement from the target system about the data transfer. But in the synchronous RFC, it will wait for the acknowledgement. Once the first document is received, and only the source system will send the second document here. The synchronous RFC, it will not wait for the acknowledgement. So quite opposite to the it is quite opposite to the your asynchronous RFC here, right? So source system has no information about the data transferred or not to the target system. That has no information, right? It has no information here. So what about the transactional RFC here? Transactional RFC here, right? So transactional RFC, it's a similar to the asynchronous mechanism only, asynchronous RFC only, but here in the source system, it will assign the one of the transaction ID. Whenever we are sending the transferring the data to the target system, it will create the one transaction ID in the source system. The users, it will create the each request will create the transaction ID to recognizing the request at remote system. It will create the one transaction ID here. So here, suppose the remote system is not available. If the remote system is not available, if the remote system is data will stay in source system itself only. When the remote system is available, data transferring will happen to the target system here. Data transferring will happen to the target system here. In the regular interval, it will transfer the data to the target system here. The only difference is here. So it will create the transaction ID to avoid the duplicates, or to identify the data in the remote system. It will create the transactional RFC, transactional ID here. In SM58 is the transaction code. Here we can see the transaction ID here. So if you go to the SM58 is the transaction code. Here we can just remove the dates here. So here, if you go to the transactional ID, here you will see the transactional RFC here. So if any transactional RFCs are stuck here, it will show, it will display the results here. If not, then we need to take the respective action here. Maybe the target system is not available. So why? Because source data is sending to the target, right? So while sending the data to the target, so here in the synchronous RFC, in the transactional RFC, it will create the transactional RFC, it will create the one transaction ID. ID will be created, one transactional ID will be created here. So using this ID, so there is no data duplication here, right? Same data, whether target received, it will ignore it here. It's not received, based upon the transactional ID, it will transfer to the target system here. So let me see. So I think we have other systems here. Maybe in the ECC, let's check whether we have any transactional IDs got stuck or not. Let's check here.
Hi, sir. Hi. Sir, in the transaction RFC, target system should be available or not, sir?
So target system should be available or not, don't care. It should not be available. Either it's available, fine. It's not available also. it will keep the data in the source system itself. Like this, in the transactional ID, the data will keep it in the source system itself. Here you can see the source system, it will is available. There is a data locking. In this data locking program, so all the transactions got stuck in the system. All the transactions got stuck in the SAP system. But each and every transaction, there is a one transaction ID created. Transaction ID, it is created. So as and when required, if the target system is available, it will automatically, it will process the data to the target system. Via this ID, it will process the data. In case of this transaction is already exist in the target system, so then it won't process this transaction. Remaining transactions, it will process it here. So in the transactional RFC, so whether it kind of asynchronous RFC, which means even target is not available also, data will stay in source. Then whenever the target is available, that time it will transfer the data. So that's why you can see here the transactions are available here.
Sir, from here, I have one more question here. How, if the server, how does it know that the server is available or not? I mean, at any particular time interval, it will check or how it will be?
It will check. There is a job, actually. There is a internal jobs in the something RS ARFC. There is some internal jobs. It will check. It will check it out whether the destination is available or not. It will check it out. If the destination is available, pinging, then it will transfer the data to the respective target system. Here it will transfer the data to the respective target system. So those transactional RFCs, we can see it here. Those transactional RFCs in SM58 transaction code, we can see it here. So here it will clearly display the, so what is the, who is the caller initiated the transaction, what is the destination, which time, and what is the short text here, what is the transaction ID. Then, so all the information, you will get the details. What is the program here? So it will give the details here. So there is a program actually. There is a program in SM37. So there is a program actually. That program, the program related job, it will cross check here RS ARFC, RS ARFC SC. So there is a program actually. So if the program is started and running, it will check. It will check the whether the jobs are running or not. If the job is not running, it will clearly check. It will transfer the data. You can see ARFC, the jobs are running now. So it's running. So it will transfer the data. Daily it is running. You can see daily it is running. So target gateway is not active. So it is checking. It is checking here. Just one. Yeah. Sorry guys. So here you can see the ARFCs. So this program, actually this jobs will be initiated by the program here, ARFC SC. So this will check the field RFCs, this will check thoroughly. So then it will transfer the data to the, so the target gateway active. So see here, so every day, so the jobs are, it is assigning. You can see target gateway is not active. Then, so then it is the transactions are failed here. So it will check thoroughly, it will check it out, it will transfer the data to the systems here. That is called the transactional RFC here. Why? Because when transferring the data from source to target, so it will create the one transaction ID. It will create the one transaction ID at source. Then, so while it transferring to the target is available, it will transfer the data. If not available, the data will hold in source itself. So then it will keep on checking to the target whether target is available or not. Then it will transfer the data to the target system. That's what will happen in the system. That is called the transactional RFCs. Okay, so SM58 we can find out as part of the regular monitoring, daily monitoring, what we need to check here. So like daily, while doing the monitoring, SM58, check the are there any transactions failed in the system or not. If it is failed, then who is the user here? Who is the caller here? So base is caller. What is the RFC destination here? Then what is the issue? Something is a user locked, notify the responsible person. User locking issue here, user locking issue. So that's the reason we have the, if this got failed here, user locking issue that got failed in the system here. So EWZ5 is the transaction code here. So the next one is the queued RFC. Queued. So queued RFC means queues wise, the data, it's a advanced version of the transactional RFC here. So synchronous, the transactional RFC is same as like a synchronous RFC. But here the only difference is transaction ID will be assigned here. The queued RFC means is a advanced version of the transactional RFC. While sending the data to the target, the request will go via queues, via order wise. Why? Because data means there are the multiple types of data here. All the data will not send at a time here. The types of data will under the queues, groups wise, queues wise, queued up, queues wise in a sequence wise, the data will be processed here. This is the guarantee the transactions are processing in order, in a sequence, in the order by the application. Thus, it is moving to the correctly, the queues are moving to the correctly or not, it will go. So here the queues wise means in SMQ1, SMQ2 are the transactions here. SMQ1, SMQ2 are the, here we can see the inbound queues. So inbound queues and outbound queues, we can check it out here. Suppose example, if you see here, so SMQ1. So here outbound queues here. Here we can check are there any queue entries got stuck or not here. Nothing, 0, 0, right? If we go to the SMQ2 inbound queues, here we can see the any queues are stuck or not. Here we can check it out here. So what is meant by queues here? So via queues, the data transferring will happen to the target system in a sequence, in a order, in a queue wise, in a order, the data transferring will happen. But here transactional analysis, based upon the transactional ID, data will go to the target system. So, but here via queues, data, we have the types of data, right? So, but each data, there is a type and a sequence wise it should process. So, first in, first out. Then here in SMQ1, SMQ2, which are related to the queued RFC, it will process the data to the respective the target systems. Respective target system, it will process the data here, right? That is called the queued RFC here. So those related things here, outbound queues and inbound queues, SMQ2 we can find out in the here, right? So here, first of all, the queues should be exist, right? The queues should be exist here to transfer. So here to create the queues here, SMQR, queue in scheduler, which is coming inside of the system. So which is coming inside of the system here, queue scheduler. Suppose the queues name is called the AB star queues. AB star data should go to the here. Then you need to create the queue. So then AC star queue, AC star data, it should go to here. Maybe BW related data should go here. Then CRM data should go to the queues. So like this, if you create the queues, so based upon the queues, the data transferring will happen to the your system. Data transferring will happen to the your system in the inbound in schedule, data transferring will happen. So queues creation we have to do it in the SMQR. We can check it out here. SMQR we can check here. In SMQ, so SMQ2 we can monitor the whether any respective queues. Queue in means inbound queues, which means inside of the queues here. Inside means which is coming inside of the system. Suppose in the same system, if you take it out, The data transferring is happening from here to source to target, which means it is coming inside of the system, which is coming inside of the system. This is called the inbound. This is called the inbound here. Inbound means here SM Q2, SM then SM, so QR, here we can create the queues and we can check it out here. SM, so inbound means SMQ2. Two, we can check the inbound queues which is coming inside of the system. Anything got stuck which is coming inside of the system here, right? Then SMQR, we can create the entries here, queues we can create. Via this queue, the data transferring will happen here. So how they will define it means they will the recording or from their side they will define the queues. All those things they will define it here. So these are the queues we can create it here, right? So then SMQS outbound queues, outbound which are going out. Out means so which are going out. So which means this is called the outbound queues. This is called the outbound. This is called the outbound. So then which means which is coming outside this system outbound, then this system inbound. Then every system there is a inbound and outbound. So which is coming in, which is coming inside of the data, right? This is called the inbound queue, which is going out. Out means outbound queues here. So outbound queues means here SMQ1, SMQS, right? So here the outbound queues creation. Queues creation means going out means definitely there is a destination, right? Definitely there is a destination here. So that destination we need to create it here. The destination we have to create it here. Why? Because it's going to the out means via destination, via RFC destination only, right? So that's the reason via RFC destination, it is going to the outside of the system here, which is going outside of the system. So I have created the RFC destination here. So like this, you can create the few more RFC destinations, which are target systems, respect to target system. Then we can transfer the data here. We can transfer the data here. Like this, we can transfer, we can create it here. So via this RFC destination, we can transfer the data to the respect to target system, queue out scheduler here. So if anything got stuck here, so with anything got stuck here in SM, so SMQ1 outbound scheduler out, which is going outbound scheduler, we can monitor it here. If anything got failed, then we need to take the actions here. Actions means we need to inform to the respective so team we have to inform it here. Why? Because data means either functional team or functional team responsibility here. So we need to inform to them, then they will take care of this. Any failed entries or anything, they will take care of that one here, right? So this is about the so queued RFC here, inbound queues, outbound queues, and inbound queues creations. Queues creation means so SMQR, SMQS. So SMQS, so someone already created here. Then RFC destinations. Then inbound means SMQS. So like this, we can create it here, the queues creation. One-time activity. This QR, QS are the one-time activities here. One-time activities, we can create it here, one-time activities here. But here, the SM, so but these all are the one-time activities. These all are the one-time activities here. So, but to check whether data is transferring, data is coming inside of the queue or not. So here we can check it out whether the data is got stuck or not. Here we can check it out here whether we can check it out here. So that's what we can do it in the system here. That's what we can do it in the system here. Suppose let me create the some data here. User logged successfully too. Then user unlocked users too. So might be it may create some data here. SM58. Let's see. Same system, right? I don't think it will create the new data, but let's see here. So nothing is created. These all are the failed on the 8th one. 8th one, it got failed. It got failed 8-1. Okay, that's fine. After that, data failing is not happening. The data is moving to the systems here. So like this, we can check the queues here, inbound queues, outbound queues. So qRFC means queues wise, queue via queue. So how when you go to the outside, we have the queues, right? In the queue, how we will so carry out our works here. Here also via queues in a sequence, order wise, the data transferring will happen to the source to target system via queues using the queues. So it will go. So this is called the queued RFC. This is called the queued RFC here. Right? Any questions? Anyone? Queued RFC.
So, sir, in real-time scenario, when we use this type of RFC.
So queued RFC normally this is the guarantee RFC. So reliable RFCs. So when you are transferring the data, suppose in ECC we have the transactional data. That data will be transferred to the respective CRM systems or BW systems. That time, so using the queues, the data will be transferred to the respective target system. So in the real time, so from one system to other system, when you are transferring the data, that time this will happen.
Okay, sir. Okay. Transaction also same, sir. tRFC also.
Yeah, tRFC also. These two will be used actually. They will use these two transactional RFCs and queued RFC here.
So, in transaction RFC, data when will be locked, we will re-import the data, sir. Automatically
Yeah,
will.
it will take care of actually. It automatically it will when the target as soon as target is available based upon the job, it will move to the respective target system here, the transactional RFC. TID, the transactional ID will be generated. So while transferring to the here, the same data is available here or not. If it is not available, then it will transfer the data. If it is available in the source system, it's a the data already exists in the target system, something like that. You will get the error message here. So this program, it will run regular intervals and it will try to place the unsuccessful request into the target system here.
Okay, sir. Thank you.
Hi, sir. Sai here. Sir, if we find any duplicate transactions in the SM58, can we cancel those records, sir, from?
Yeah. From our side, so what we will do, we will inform to them. Okay. So in case they told that they don't have the authorization, they asked us to clean up. So then we can clean up here. We can delete it. There is an option. So there is an option to delete it. Yes, you can see there is an option to delete the entry. So just you can go to the here, you can just reorganize or delete here. So we can delete the entry here. If you delete it, the entry will be gone.
Okay, sir. Same like can we resume the structured RFC, sir, here?
Yeah, suppose if you want to process that RFC, you have the execute LUW, right? Suppose like you can see this is the transaction ID. So 20005. Okay, just select it here. Go to edit, execute. Yes, it got processed, right? 2005 processed. Now last digits you can see 2006. Then just click on the execute. Then that is also processed, right? So it is processed. The data got processed.
Okay, sir. Thank you, sir.
Yeah, we can reprocess or we can delete it here.
Thank you, sir. Thanks.
Okay, so that is about the types of RFCs. Then what next? We will discuss. So shall I discuss small topic or will you guys practice?
We will practice, sir.
Yes, sir.
I will send you the one of the monitoring sheet. So just you can in the real time also daily basis we may have to do that monitoring all the transaction codes and everything. So let's see. Okay, I will send you the details in the group just to practice it. So tomorrow we'll go with so we have some performance related transaction codes and a daily monitoring transaction codes and also some other transactions are available. Scott email configurations, outbound emails, inbound emails configurations, they are there. Before we go for the transport administration, the small topics, we cover it, then directly we can jump into the big topics like transport administration, note implementations. So some other topics we can discuss it here. The small topics we will complete it. Okay. So just practice it. This initial practicing is very important. So then, why? Because when we go for the next topics, you will not get time to practice these things here. So that's why. So we'll go slowly, but please practice it here today. Okay.